Hello, everyone. My name is Nick Gopi. I am part of the American Chemical Society, and this is our YouTube channel. Today, I would like to introduce Dr. James Bour, our newest assistant professor at Wayne State University in the chemical department. Dr. Bour, how are you doing today?
I'm doing very well. It's great to be here.
Thank you for being part of this. Tell us about some of your inspirations.
As far as my career goes, at least, I've taken a pretty a standard approach. I would say, I did the undergrad thing, and then I went right on to graduate school. But really, what compelled me to go to graduate school was lab work. Like many others, I was a maybe pre-med. I don't know what I was. I was just kind of drifting in the ether. And then I took organic chemistry, and like many people, that really changed maybe small aspirations of pre-med. But for me, I was just so enthralled with the subject matter and sort of the qualitative puzzle solving. So I knew I wanted to be involved in that some way. So I signed up to work in an organic chemistry lab and had a really influential mentor. So I'd say the biggest inspiration for me was that influential mentor. I think a lot of people in science have that person who really just invested in them and gave them the time it takes to get brought into such a difficult field. And so I found him really inspiring. I really wanted to take that same path, and the next step was graduate school.
And what was your mentor's name?
Jeff Johnson. So I went to Hope College on the other side of the state. He was very kind with his time and a really inspiring mentor. And I kind of wanted to do that track. And my plans changed a little bit after I left undergrad, but that was really my main inspiration, was having an influential person in my life who really inspired me to do research and to discover new things.
So in your career thus far, have there been any moments of challenges and the path you took in your career?
Absolutely, yeah. There have been many challenges. I mean, it's not an easy path. I had some challenges in my fourth year of graduate school, and then the biggest one was actually during my postdoc. I would say the biggest challenge was applying for faculty positions. By that point in time, I really wanted to be a professor, and I was planning on doing a standard 3-year postdoc, but some family stuff really made it so it was imperative that I come back to the Midwest, which I know and love, but wasn't planning to do that year. So that put a real limit on my time as a postdoc, and really only gave me one chance to apply. And it's a competitive job market, so that was a huge challenge. Was rising to that and really putting all that stuff aside and making it happen so that I could tend to my family stuff and take care of that, as well as pursue my career aspirations.
What is your favorite part about being a faculty at Wayne State so far?
So yeah, I'm pretty new to it, so it's hard to say what's going to be my favorite thing in 5 years. But I'd say right now, it's definitely my colleagues. They've been super great and helpful and looking out for me. I've gotten calls, at 8 o'clock at night saying, "James, I saw this, and I think it would be better for your research program if maybe you had rotators out at this time of year," and things like that, and just giving me insight into the process, because there's a lot of things they don't teach you about being a professor. And my colleagues have just been so supportive, particularly in the organic division, but really the whole department. It's been a really welcoming environment. So I would say so far it's definitely the people here.
Could you give us any details or insights on the classes you teach and how students can be successful in your classes?
So this semester I'm teaching chemistry 6200 and 7200. Those are just the same course, but one's the undergraduate listing. That's organic mechanisms. And so the first 3 weeks of the course are related to reviewing, because for many people it's been 2 or even 3 longer years since they've taken organic chemistry. So we're just getting the basics back down, refreshing everybody, and we're moving into organic mechanisms, which is actually like one of my all-time favorite topics in organic chemistry. That is just these wonderful problems, pictorial problems that I really enjoy working through. And so I would say when I took this class, the number one thing that I did incorrectly, and what I would recommend for students in my class to do, is to really honestly assess whether you understand why something's happening. It's so easy to sit there and lecture. I think we've all been there, to sit there and you're like, "Oh, this makes perfect sense. What the professor just said is great. I understand it. Moving on. Like, I'm going to get an A on the test." And you get to the test and you realize you didn't actually understand. And what I found is that that's a question you can ask yourself when you're studying. You can say, "Okay, this is the way things are. I came to the same conclusions what we talked about in class. But why isn't it this alternative possibility?" To really stretch your mind and think about what alternatives we didn't talk about, how deeply you understand it, and if these alternative things that sound reasonable are, in fact, related to what you're studying. So.
Do you have any general advice to undergraduate and graduate students?
Yeah, undergrad, it's a little bit tougher because your path is a little bit more clear. Like the objectives that you have to do, you have to take the exam, get the grade, get the degree. Those are a little bit more clear. And so I would say one of the better decisions I sort of made inadvertently as an undergraduate that really ended up helping me in the long term was to pursue classes outside of my major. And I didn't really know what I was interested in early on in undergraduate, and that sort of became more focused. But even through undergrad, I definitely took some classes that were pretty far out there for my major, at least at face value, and I really benefited from them. So I would say, it may not seem like it at the like right now if you're an undergraduate, but I think it's really good to branch out and to really work hard on finding out what inspires you. For graduate students, I guess I would say something that I definitely could have benefited from and been more deliberate about was coming into lab every day with a plan. I guess that's a little bit specific to physical sciences, or life sciences, but it's really easy to get to your third year and have that post candidacy, post independent proposal certainty of your position, and to kind of just come in and not get that much done. And you can get a lot done in 8 hours if you come in with a plan, how you're going to do it, and then hold yourself to that every day. So I would definitely recommend knowing what you're going to do before you come in and having a very clear idea of how you're going to do that.
Are you currently working on any exciting research that you'd like to share with us?
I could definitely talk about what I would like to be working on, but unfortunately, just getting started, so not too many things come through yet. But my group is generally interested in catalysis, and we're interested in sort of the interface of solid phases and solution phase catalysis. So we're going to work on new materials, and we're going to work on solution phase catalyst assemblies that really seek to address one of the grandest challenges in all of synthetic chemistry, and that is reaction selectivity. So we're trying to go about controlling how a catalyst processes a substrate and spits out a different product in a different way. We're using these unusual materials, these porous materials, as well as solution phase platforms to do just that, to address the selectivity problem from a different angle. And so I'm really excited to see where that will go, sort of the overarching goal of our lab.
That does sound really interesting. No, when you say unusual materials, like what are you talking about? Like,
that's a great question. So I'm interested in, I guess my word for material, it might be a little bit different than other people's. Material I'm just using to refer to any system, whether it be in solution or solid phase, that we work with to realize new and interesting emergent properties. And so the reason I call them unusual is because we're going to try to manipulate existing systems in different ways than people have gone about it. And so in solution phases, we're really focused on large catalyst architectures whose domain sizes are much larger than a conventional solution phase catalyst. And so in that area, we're really focused on pursuing transformations and pursuing chemical selectivity that's best suited for solution phase. Think like a polymerization would be very difficult to have a solid phase catalyst for, because pores and things would get clogged. And then in solid phases, I would call them unusual materials because we're going to manipulate these materials with the sort of chemical precision typically associated with solution phase chemistries. And that's something that's sort of an outstanding challenge in material synthesis, is how do we control their structure, activate that amide versus, that ester or something like that. That's very difficult to do in the solid phase. Your options are a lot more limited. And a new class of materials that are based on organic frameworks, that are primarily organic, have really changed how people think about synthesis in the solid phase and what can really be done and how we can treat these materials as if they were molecules in solution. So the materials, the solids we're going to work with are unusual in that respect, and that we have atomic level precision over how we manipulate them. And that's really powerful for realizing new reactivity.
That's some very interesting research that you're working on.
Thanks.
So what was it like, starting up your lab, like, pre and during COVID?
So, I accepted the job offer at Wayne State in late February. And then about 2 weeks after that,
Everything changed.
Everything changed. And so I guess I don't have too good of a sense on what it was like to set it up pre-COVID. Of course, I had thought about it before as I applied for jobs, before I even knew what coronavirus was. But after COVID, it's been pretty difficult. It's been really tough. Things are moving a lot slower. My lab is not as full as I want. I'm waiting on instruments and things like that. And, I think what this pandemic has really reminded me and is important to keep in mind is that, everybody has challenges in their life, and something like this really exacerbates those. And that pops up in people's work, understandably. It's been tough, but I'm just really excited to be here and get to work with bright and inquiring minds every day. So it's been great.
Why did you choose Wayne State?
Oh, that's an easy question. It's easily the Detroit community. So, when I'm sitting here late at night, like grinding out grants, I want to be sure that those research dollars are, contributing to a community that I care about. And, research is a big industry, and is a real source of income for an area. And Detroit is really near and dear to my heart. So I don't know if I've ever told anybody this, but I'm a native Michigander. Okay, so then there's the Detroit connection there. But actually, both my grandparents, both my parents, and my wife are all proud Wayne State alums. So the school's given my family a tremendous amount of opportunity, and I'd really like to be a part of that same community. So I know Wayne State really well. I know it's a fantastic institution, and I'm really excited to be, here at this specific school, not just Detroit, but this specific school. So it's really a confluence of just a bunch of factors that I really care about on the personal level. And so it's a no-brainer for me to come here.
All right. So do you have any advice for anyone pursuing a graduate degree?
Definitely. I guess like most of these things, I can only speak from experience, but one thing I really struggled with early on in graduate school was decoupling success and failure from, your sort of self-worth. It's a pretty uncertain process, and the uncertainty of graduate school is very, very difficult. And I think this is true for any graduate student, but especially in the sciences, where you get some good data and that can really improve career prospects and things like that, or things aren't working. And for me, when I was an undergraduate, there was a very clear correlation with effort to outcome. I didn't prepare for that calc exam; it didn't go so well. If I really, started studying for that Gen Chem final 3 weeks in advance, I did well. And so there was this nice correlation where, I kind of got what I deserved in terms of studying. In graduate school, that's not the case. Some of the smartest people I know worked for 3 years on a project that at face value makes perfect sense, but it just doesn't work. It's not in the cards. And so, if you want to be, I would say if you want to be a happy person in graduate school, you really need to separate those two worlds and realize that you may be a brilliant and successful scientist and not have the projects working. And that's just the way it is. And that's how it is for a lot of really smart, really motivated people. On the other side of that, I would also say you can't let success go to your head, because it could just be due to random chance. I've certainly had my share of both situations where I had easy projects and really hard projects where I did everything right and just wasn't there. So decouple those two things, and I would say you'll be a much happier person.
Oh, that's all the questions. I appreciate you taking your time, Dr. Bour, and we look forward to seeing you on campus post-COVID.
Absolutely. I'm really excited to be here and meet everyone and get to it. Get some great research done. So
thank you.
All right. Thank you. Have a great day.